and welcome to Math 252. In this lesson, we are going to discuss about Mid-Ordinate Rule. Mid-Ordinate Rule is one of the rules that are normally used to approximate an area under a curve, or one of the rules that are used in approximating an area. In our previous lesson, we discussed about the trapezoidal rule or trapezium rule, and we have seen how we can derive that rule and how we can apply it in calculating or approximating an area under a curve. We shall do the same to this. We shall derive the rule. Then from the derivation, we shall also have one example on how we can use this particular rule. So let's start. Consider the diagram given below. This diagram that we have is a curve whose equation is y is equal to x squared plus 4. We have area that is bounded by the curve y is equal to x squared plus 4, and the lines y-axis or x is equal to 0, the x-axis, and the line x is equal to 4. So to derive the rule, we shall be using the area bounded by this curve and the lines that I have stated, and this is the area that I have divided. So starting from y is equal to, in the line y-axis, the x-axis, and the lines x is equal to 0 and x is equal to 4. Okay, so we can divide the area of the curve and the curve into 4 portions. That is A, B, C, and D. That is, we have subdivided the area under this curve into 4 different rectangles. In trapezium rule, we said we divide the curve or the area under curve into different trapezia, but in mid-ordinate rule, we subdivide the area under curve into different rectangles. So we are divided into rectangle A, B, C, and D. The height of all rectangles are represented by H. So all of them, the height of the rectangles are H. This is H, and all of them are equal. Then the width of the rectangles are Y1, Y2, Y3 for C, and Y4 for D. So the area of this region will absolutely be equal to the sum area of these 4 rectangles. You can have as many rectangles as you want, and the accuracy of this type of approximation normally depends on how many rectangles or how many trapezium that you have in both cases. So the more that you have, the accurate the area will be. So area of rectangle A plus area of rectangle B plus area of rectangle C plus area of rectangle D will therefore be equal to the area of this curve that we are using our case study as our case study. So area of A, that area of a rectangle is always equal to the length times width. That is, in this case, the length is H. So the length is Y1 and the width is H. So that becomes Y1 times H. That of B will be equal to also H times Y2. H is common for all of them. So it is H times Y2. That of C becomes Y3 times H. And then lastly, that of D will be equal to the Y4 times the width, which is H in this case. So to get the area of the region now, we shall be adding all these areas. Therefore, the total area will be equal to Y1 times H, that is the area of A, plus y2 times h, that of b, y3 times h, that is of C, and y4 times h, that is the area of D. This will be the total area of this region bounded by the curve and the different lines given. Then we can factorize, because since we have h as common, it is appearing in all our areas, then we can factorize and put h outside, and therefore this will be written as h into y1 plus y2 plus y3 plus y4. So total area of this region will be y1 plus y2 plus y3 plus y4 times the common width, which is h in that case. What this one implies is that the area of a curve using a mid-ordinate rule is always given by the height of rectangles. Height of the rectangle, that is h, which is common for all of them, times the sum of all y's. So individual y's, you add them together, even if they are 10 or more, you add them together and then you multiply with the common h. This is the area, how we can get the area of a curve using a mid-ordinate rule. So note, we have certain points that we need to note, that in mid-ordinate rule, h is given by b minus a divided by n, where b in this case is the upper limits. So in our case, we are given x is equal to 4 and x is equal to 0. So x is equal to 4 is b in this case, while x is equal to 0 is a. So you take upper limit minus lower limit divided by n, where n are the number of strips. And in mid-ordinate rule, the number of ordinates is equal to the number of strips. While in trapezium rule, we said the number of ordinates are always one more than the number of strips, but in this case they are equal. Then point number 2 is that the first x in mid-ordinate rule is always given by a, which is the lower limit, times a half of h. That if you want to get the first x, then it becomes a, which is the lower limit, plus a half of h, and this is how we said h can be calculated. Then lastly, the remaining x's, that is the subsequent x, are h apart, that the difference between any two x's will be the value of h. So if you have the first x as this one, then the second h will be equal to x1 plus h, while that one becomes x2 plus h. Those are the subsequent h, how you can obtain them. So I think those are the most important thing that we basically need to say on mid-ordinate rule. So let's see the one example on how we can apply this rule. Examples. The diagram below is a sketch of a curve y is equal to x squared plus 5. The curve is shown in the diagram. The sketch of curve is y is equal to x squared plus 5. Then the question is, use mid-ordinate rule with 6 strips to find or to estimate the area enclosed by the curve, the x-axis, the y-axis, and the line x is equal to 3. So we need to get the area bounded by the y-axis, that is the x is equal to 0. So the lower limit here is 0, and the upper limit is x is equal to 3. So we shall be calculating area bounded by the curve and those lines given. Solution. So we need first of all to get the value of h. H we said is always given by the upper limit minus lower limit divided by n. Those are the number of strips. And therefore h will be equal to 3 minus 0 divided by number of strips, that is 6 strips. So 3 minus 0 divided by 6, that is 3 over 6, which is equal to a half, or 0.5. So the value of h is 0.5. Then after obtaining the value of h, then the next one that we need to get is the first x. The first x we said is always given by a plus a half of h. A plus a half of h, and a in this case is 0. Then we add a half of h, that is a plus a half of 0.5, which is equal to 0.25. so our first x is 0.25. so after obtaining the h, the value of h, and obtaining the value of x1, then we need to get now a table of content that comprises the x and then the y. The values of x will simply be 0.25, then the next one will be 0.25 plus 0.5. we continue until we get the number of strips wanted. Then we get the value of corresponding y by substituting the value of x in the equation of the curve given. So if x is 0.25, what will be the value of x? I have tabulated this one and I have obtained these values as the value of x and the corresponding values of x of y. So when x is 0.25, y is 5.06, and when x is 0.75, y becomes 5.56. The way I am obtaining the x, as we said, we simply take the first x, that is 0.25, and then we add the value of h. So 0.25 plus 0.5 is 0.75. 0.75 plus 0.5 will give you 1.25. That's how you can get the corresponding values or the subsequent values of x, and then the corresponding value of y are obtained by substituting x 0.25 in the equation of the curve that you had, that is x squared plus 5. You get the corresponding value of y individually, then you continue until you get the last value as 12.56. Then from our rule that we said, area under a curve using mid-ordinate rule is equal to h times the sum of all y's. So we take the height, which is 0.5, then in bracket all the values of y, that is 5.06 plus 5.56 plus 6.56 plus 8.06 until 12.56. So you add all these one using your calculator, then you multiply 0.5 again. This gives you 0.5 plus the sum of these will become 47.08. So it is 0.5 times 47.86, and finally the answer becomes 23.93 square units. That is how we can apply the mid-ordinate rule. I hope you have enjoyed. Please don't forget to subscribe and share with your friends. Until we meet for the next lesson, I wish you all the best.